Ever wonder how those incredibly smart AI chatbots manage to stay so current? Even on breaking news or really niche topics, they're often powered by something called Search-Augmented Large Language Models, or LLMs. Today, we're taking a deep dive into a truly fascinating academic paper. It really pulls back the curtain on how these advanced AIs actually work, and not just how they work, but how we interact with them and what truly makes a response good, or maybe surprisingly, not so good. Our mission for this deep dive is to unpack the groundbreaking research from the search arena, analyzing Search-Augmented LLMs paper. We're going to walk you through the structure of their study. Just like in the paper itself, you'll get a hopefully crystal clear understanding of the big challenges in evaluating these models. And we'll uncover some really surprising factors that influence user trust. Get ready for some serious aha moments because, well, this study reveals a lot about our own biases when we talk to AI. Okay, let's unpack this. We'll start right where the paper does, with an introduction to these search-augmented LLMs and the core problem they're trying to solve. We've all seen the incredible capabilities of large language models, LLMs, right? Generating human-like text, holding conversations. But at their core, they face a fundamental limitation, don't they?
They absolutely do, yeah. LLMs primarily rely on static training data. Think of it like a massive library, incredibly well organized, sure, but one that was completely frozen at a certain point in time. This means they can really struggle with time-sensitive questions, emerging topics, or, highly specialized areas that just weren't in that initial training material. What's really ingenious here is how these search-augmented LLMs bridge that gap. They do it by actively retrieving and integrating live web data right during the conversation. This lets them offer responses that are up-to-date, highly specific, and, importantly, factually verifiable. It's a real game changer for relevance.
So it's kind of like giving the AI a live internet connection, transforming it into an instant expert on almost anything, anytime.
Pretty much, yeah.
But that sounds almost too good to be true. What's the catch? How do you even begin to measure how effective something so fluid and new is, especially when the old evaluation methods seem, well, kind of rigid?
That's exactly the challenge. And it raises a critical question. How do we genuinely get a handle on user interaction with these hybrid systems? You see, prior evaluation datasets, things like simple QA or browse comp, they were just too narrow for this new type of AI. They were typically small scale, often focused on single turn, pretty straightforward fact-checking questions, and mostly just in English. If we step back and look at the bigger picture, real-world user queries are just so much more complex and diverse. The Search Arena study found something really eye-opening. Fact-checking. That's only about 1/5 of what people actually ask. The vast majority require much more complex tasks like reasoning or providing recommendations or even sophisticated problem solving. And user expectations go way beyond just factual correctness. People care a lot, actually, about citation quality and even the style of the response, how it's presented. This huge gap is exactly what the Search Arena research was meticulously designed to fill.
Right. Which brings us nicely to the next part of the paper, their solution. How did the researchers at UC Berkeley actually build this search arena? How did they capture what real users are doing out there in the wild? It sounds like a huge undertaking.
It truly was ambitious. To tackle this, they launched an open, crowdsourced evaluation platform. They cleverly integrated it as a separate tab within the already popular chatbot arena. You might have used it. Over a focused 7-week period, March 18th to May 8th, 2025, they gathered just an astonishing amount of data. We're talking over 24,000 unique conversations and, get this, 12,652 paired human preference judgments, where people said, I prefer model A over model B. And this wasn't from a small select group either. It came from a remarkably diverse base of 11,650 users, spanning 136 countries, all interacting with 13 different advanced models. The scale alone is pretty unprecedented.
Wow, that is an incredible scale. It's something that really jumped out at me here. It wasn't just in English, was it? That feels like a massive step forward from earlier work.
You're absolutely right. That's a key point. The dataset boasts substantial linguistic diversity. We're talking over 70 languages represented. Now, English was the majority, around 58%, but Russian was nearly 12%, and Chinese was 7%. Significant chunks. And here's something crucial. Over 11% of the prompts were actually multilingual, mixing languages in one query, which reflects how people really search and interact globally. What's equally fascinating, though, is the conversational diversity. Over 22% of interactions were multi-turn conversations. Real back and forth, follow-up questions, genuine dialogue. That's stark contrast to the single question focus of older benchmarks. And the prompt lengths were all over the place, too, averaging over 57 words, but covering everything from super brief queries to long, detailed requests. It really gives us a holistic view.
Okay, so with all this incredibly rich, diverse data, did we finally get a clearer picture of why people are using these search-augmented AIs? What does this massive data set tell us about user intent?
It certainly did. And this is where the paper delivers a really significant insight moving into their analysis phase. The study introduced a new taxonomy, 9 categories, specifically for user intent in these search-enabled interactions. Things like factual lookup, information synthesis, analysis, recommendation, explanation, creative generation, guidance, text processing, and a catch-all other. Now, here's the real aha moment from this section. Factual lookup queries are the main focus of older datasets.
Yeah.
They accounted for only 19.3% of the prompts, just under a fifth.
Wow, only 19%.
Right. So forget what you might have thought AI chatbots were primarily for. This study basically blew open the old assumption that people just want facts spat back at them. It turns out a staggering 80% of the time users are asking these AIs to think, to reason, to solve problems, synthesize information, generate creative content. Not just parrot back what they found. This isn't just a minor adjustment in our understanding. It's a complete redefinition of how we're using these powerful tools. We're moving far beyond simple fact-checking into much higher-order cognitive tasks.
That is a truly profound shift in understanding user behavior. Okay, so Section 3 of the paper then looks at preferences. With all these human votes collected across such a diverse data set, what did they discover? What actually makes users prefer one response over another in this complex new landscape?
Right. So to understand what drove those A versus B choices, the researchers use a clever statistical technique, the Bradley-Terry model. You can think of it like a sophisticated tournament bracket or leaderboard. It helps figure out which model characteristics are truly winning based on all those head-to-head user comparisons. Their analysis broke down the influences into several key areas. Let's take the general features first. First, reasoning capabilities. Models that showed stronger reasoning, things like accurately understanding the prompt, filtering out irrelevant stuff from the search results, they consistently got higher win rates. This suggests users, perhaps implicitly, really value the model's ability to understand and distill information effectively, not just, regurgitate it.
Okay, that makes sense. What else?
Second, search context size. Models designed with larger search context windows, meaning they could process and consider more of the retrieved web content when generating their answer, they generally outperform models with smaller windows. More context often led to responses that users preferred, maybe perceived them as more comprehensive or thorough.
More information in, better answer out, generally speaking.
Sort of, yeah. But then there's the third point, response length. And here's where it gets surprising. The study found a statistically significant preference for more verbose responses. Longer answers were preferred.
Longer. Really? Even if the extra words don't add much?
Apparently so. It seems users might equate length with value or effort, perhaps. The Bradley-Terry coefficient for length was positive and significant. However, what's really fascinating is that this bias was less pronounced for factual lookup prompts. For just getting facts, users actually preferred more concise, to-the-point answers.
Ah, okay. So it's not a universal thing. Context matters.
Exactly. It tells us user preference isn't one size fits all.
That response length bias is really interesting, though. Makes you wonder if we're accidentally training AIs to be chatty rather than concise. But let's pivot to citations. That seems critical for search-augmented models. Their presence, their quality. That must be a huge factor in user trust, right?
Absolutely.
Yeah.
They are a huge factor. And this is where the analysis raises some fundamental questions about perceived versus actual trustworthiness. The findings here are quite telling, maybe even a bit worrying. First, the number of cited sources. Pretty straightforward. Users clearly favored responses that had more references, more citations, higher preference score. Quantity seemed to matter.
Okay, more is better in the user's eyes. What about the type of source?
This is where it gets really interesting and maybe a bit counterintuitive for some. Users showed a preference for responses, citing tech platforms like Stack Overflow, community platforms like Reddit or Substack. Even social media like TikTok showed a positive correlation.
TikTok.
Seriously. Beta coefficient was positive. But here's the real kicker. Citing Wikipedia was negatively correlated with user preferences.
Wow. Wikipedia was bad.
Negatively correlated, yeah. Think about that. The go-to source of compiled knowledge, often viewed with skepticism when an AI uses it. Now, the researchers speculate this could be because Wikipedia articles are often broad, maybe too lengthy, or perhaps just not perceived as real-time enough for certain queries. It forces us to rethink what authority means to users in this AI context.
Definitely food for thought. But what about the accuracy of the citations? Did that matter?
Well, this leads to perhaps the most surprising and frankly concerning finding of the whole study, what they termed the credibility gap.
Hmm.
While having supporting citations did positively correlate with user preference, as you'd hope,
All right.
the study also found a significant positive association between user preference and the number of irrelevant citations.
Wait, irrelevant citations made people like the answer more.
Correct. Users were swayed by the mere presence of citations, even when those citations didn't actually back up the claims the LLM was making.
Yeah.
And even more startling, contradicting citations, ones that disagreed with the AI's point, showed no significant negative effect on preference.
That's genuinely alarming.
It is. It highlights this critical credibility gap.
Mm-hmm.
Users see citations, visually perhaps, and perceive the response as trustworthy, even if the citations are misplaced, irrelevant, or even contradictory. It's like we're cued to trust the look of being sourced without always checking the substance.
That credibility gap is a huge finding.
Wow. Okay, so moving to the next piece of their analysis. What does all this mean for how these models perform in different situations? Like, is a search-augmented model still good in a regular chat? Does it lose its edge if the user isn't specifically looking for web results? Yeah, that cross-setting analysis in the paper is quite insightful. It helps clarify the actual value add of search augmentation. So, the researchers did this experiment. They put a search-augmented Gemini model into the text arena. That's a general chat environment where users don't explicitly expect web access. And they compared that to how a non-search model performed against search-augmented models in the search arena, where users do expect web results.
Okay, so comparing with and without the search expectation.
Exactly. And here's what they found. In the text arena, the general chat setting, the search-augmented model performed comparably overall to its non-search twin. In fact, it was even preferred for factual lookup and information synthesis queries, suggesting that its ability to pull in precise grounded data is valuable even when users aren't specifically asking for a web search. The non-search model was slightly preferred only for text processing tasks, maybe due to differences in style or conciseness, perhaps.
Interesting. So search doesn't hurt and might even help in general chat. What about the search arena?
Well, that's where the situation completely flipped. In the search arena, where users expect web access, the non-search model significantly underperformed. The gap was huge, especially for factual lookup and information synthesis, queries the very tasks where having live data is most crucial.
So the expectation really matters.
It does. And if we connect this to the broader implications, the conclusion from this part of the study is pretty clear. Web search augmentation generally doesn't hurt performance in non-search settings, and it can actually improve factual accuracy by grounding the model. It provides that factual backstop. However, relying solely on a model's internal pre-trained knowledge, what the paper calls parametric knowledge, it just isn't enough when users expect real-time, grounded information. It's like, asking someone who's only read encyclopedias from 10 years ago to comment on today's breaking news. They'll just lack the necessary up-to-date context.
That makes perfect sense. Okay, this deep dive, following the paper's structure, has given us an incredible look into the nuts and bolts of search-augmented LLMs design, user interaction, preferences. So, stepping back now, like the paper does in its final sections, how does this specific research fit into the bigger picture of AI development? And what are the crucial next steps for this field?
Well, this work really is a significant contribution, primarily because it uniquely provides this large-scale data set of real human-AI interaction traces linked directly to those human preference signals. That fills a really vital gap in both LLM development research and traditional information retrieval research. It connects the two fields in a very concrete way. Now, like any study based on crowdsourced data, it does have limitations, which the authors acknowledge. There are potential demographic skews in the user base and, of course, the inherent subjectivity of human judgments. You like blue, I like red.
Sure, always a factor with human data.
Always. But the researchers did take important steps to mitigate these issues. They anonymized the model responses, they randomized the order in which models were presented during the comparisons, all standard techniques to reduce known biases like position bias. It seems like a robust foundation for future work.
That's good to hear they address those limitations head on. So, considering everything we've uncovered, the user intent shift, the response length bias, and especially that credibility gap, what's the big, maybe provocative thought you'd leave our listeners with? What single idea should they really chew on?
The most critical, and I think maybe the most challenging takeaway, has to be that credibility gap revealed by the citation analysis. It's quite stark. We've learned that we as users seem to be swayed by the mere presence of citations, even totally irrelevant ones. We misperceive them as signals of factual accuracy and trustworthiness. This raises a really important question for all of us, I think. As these AI systems become more deeply woven into how we find information, how do we ensure that their apparent trustworthiness actually aligns with their actual factual accuracy? For future work, improving citation attribution, making absolutely certain that citations genuinely support the claims they're linked to, rather than just being decorative fluff that seems paramount. If we want to build genuinely trustworthy search-augmented LLMs, it's not just about getting information anymore. It's about getting verifiably accurate information. And critically, having the tools and maybe the skepticism to tell the difference.
Verifiably accurate. That's the key. And that's our deep dive into the Search Arena paper. We followed the research, explored how these search-augmented LLMs are being evaluated, uncovered some surprising user preferences for things like response length and citation sources, and we identified that critical credibility gap where sometimes the look of being cited can be more influential than actual accuracy. Maybe next time you ask an AI a complex question, you'll look a little closer. Where does it get its information? How is it presented? And what might that mean for what you choose to trust? Keep that curiosity alive, and we'll see you on the next deep dive.